so we'll do one motion problem here. Let's talk about this. Now, this is one of the coolest things we're going to do, especially if you're a physics person. If you're not a physics person, you probably could care less. And all I'm telling you right now off the bat is acceleration due to gravity is negative 32 feet per second squared. If you're more of a meters per second squared type of person, then you feel free to substitute the acceleration for meters per second. But it really should not matter, especially since we got a height of 8,000 feet. If you want to go meters, you get a little bit of problems. All right, so let's go back over things. If we have displacement, usually s of t, the derivative is equal to your velocity. So if you take a derivative of position in terms of time, you get velocity. If you take the derivative of velocity, we get acceleration. So now, if I want to go from acceleration to velocity, I have to take the antiderivative. So we're going to take the antiderivative of a of t dt, and that gives us v of t. Okay, so let's see what we get. We'll take the antiderivative, 32. And you notice I'm using t instead of x. These things are going to be in terms of t. So this is a constant, so the antiderivative of a constant is the constant times t plus some sort of c. Okay. Now, as far as the c goes, what we have to do is we have to kind of come up with some initial conditions. So I'm skydiving. Okay. What's my initial velocity if I'm skydiving? I'm generally falling out of a plane. At t equals 0, v equals 0. Okay, this is equal to v of t, right? So if I plug in t to be 0, 32 times 0 plus c equals, well, 0 is my velocity. What must c be? C is just 0, really. So I don't need the c in this case because it's plus 0. Now be careful about your t's and pluses, that's a t. Now, one thing to note here is that c value ends up being the initial velocity. So your velocity, if you're familiar with the physics, is your velocity initial plus acceleration times time. So here's my acceleration, here's time, here's velocity initial. That's where this equation comes from. If I do this in terms of just a's and t's, if I have this 32 dt, this is my, if I just make it an a instead of 32, that would be a t, as long as I realize a is a constant, d plus c, plus the velocity initial. So first physics equation unmasked. Alright, so if I want to go to displacement, the antiderivative of velocity is my displacement. And again, this could be d of t, this could be s of t, this could be x of t. It really just depends on what you're talking about, but this is our displacement. Alright, so the antiderivative of our velocity, which is 32, t dt becomes 32t squared over 2 plus c, or 16t squared. Now, if I want to go a little farther, let's keep with this for a second. Alright, so we want to find, this is equal to our displacement. I'm going to stick with s of t. Now my initial displacement was a height of 8,000 feet. So 16 times 0 seconds plus c equals 8,000. So that means c must equal 8,000. Okay. So our position is 16t squared. Oh, sorry, we have a slight error here right off the bat. Acceleration was a negative 32 feet per second, meaning it's going downwards. Now, it really doesn't matter if you have things being positive or negative, but if I want the 8,000 to be positive, I better have the acceleration being negative, because in other words, you're upwards and going upwards even faster. So all of these 32 should be negative, and the 16 just became negative. Okay. Alright, fix our little error. It was there in the problem to begin with, just missed it right off the bat. Alright, So where will I be 12 seconds after jumping out of the plane? Okay, well, that's asking where is a position question. So it's asking basically for S of 12. So what you're going to do is you're going to take negative 16 times 12 squared plus 8,000, which is 5,696 feet. Okay. All right, what will the speed be in 24 seconds? All right, so now I know speed and velocity are a little tricky, but when you're getting this, you're basically looking for your absolute value of velocity. Absolute value of velocity at 24. Okay, so we plug in our 24. So into our speed, our velocity equation, which is negative 32 times 24. And you can kind of tell that you're going to be going pretty fast. So negative 32 times 24, and you're going 768, and this would be feet per second because everything's in terms of feet per second. Now, why is it negative? Well, it's negative because you're going downwards. You pick the upwards to be positive, so our velocity and acceleration are both going to be downwards, negative. All right, last question. When will he hit the ground if his parachute does not open? Okay, so we take our displacement equation, because we're talking about height, hit the ground, and we want to find out how long we have to fall. So we want to set our equation equal to 0. So if we bring over the 16t squared, basically you have your 8,000 equals 16t squared. Divide over your 16 and then square root it. And we get 22.36. Now, here's the thing that's a little bit funny about this question is, well, we said at 24 seconds he's going to be going negative 768 feet per second. However, after only 22 seconds, he's hit the ground. So, well, what does that mean about this particular one? Is it really should be 0 because he's already on the ground. And he's been dead for, almost 2 seconds. Now, that's more of a trick question than anything else, but it's still nice to keep a word problem in perspective of reality. All right, have fun.